Hello, my name is Peter Atiyah and I'm part of the group with Sid Handu and Aditya Singh. Today we're going to be talking about an application called Stupid Cupid, which is a machine learning ML model application. So to start off with, this is our agenda for today to give you a quick background about the data, what tools we're using, the data analytics and profiling, how did we evaluate our models and how did we choose it, which methods did we use, and our findings, and kind of a comparison between the tools that we have used. Basically, our background is that we're going to do a gender selection between a male and a female in a machine learning data that tells the attractiveness or the matching between a male and a female. And basically, the data was compiled by Columbia Business School, and the participants had about a 4-minute interview, and the data was collected, and the data consisted of attractiveness, sincerity, intelligence, fun, ambition, and shared interests. And the goal of this is kind of to see how they are matching, if they like the opposite sex or not. The approaches and the tools we've used were mainly the tools, two data mining tools and machine learning tools, which are RapidMiner and Sas Viya. And the evaluation approach that we did on all of our models were the root mean squared error, the squared error root error, and the absolute root error, and the relative error lenient, which is kind of our model precision, and the correlation of the coefficient correlation in the ML model. Our methods that we've used, we've done some algorithms like generalized linear model, decision tree, deep learning, random forest, and gradient boosted trees, and neural network. So to start off with, we're going to go over our RapidMiner. So in RapidMiner, we started off by clustering kind of our data, and you can see here we had about two ways of doing that, which is the k-means and the x-means summary. And inside the k-means, we clustered that into two different clusters, and in x-means, we clustered all of our data into 4 groups, kind of a thing, to see a visualization of where is the genders, what's the high impacting columns in our data, and how to use it. Then the second part was that we ran our auto modeling inside RapidMiner, which gives us a full comparison between 5 different models, which are the gradient linear model, deep learning, decision tree, and random forest, and boosted trees. So basically what we have realized in here is that our root mean squared error was kind of sketchy. So what we mean by that is that you can see here our gradient linear model and random forest have almost a 0.3 compared to deep learning, decision tree, and gradient boosted trees have no error, which means that we have either most probably overfitting in our machine learning model. And if we take a deeper look, also our squared error had the same thing in there. And then once we took a look at our correlation, right? So the coefficient correlation shows how the data is kind of related to the prediction. So basically you can see that it's almost matching 1. And for the decision tree and gradient boosted trees, it's complete 1. So which means that it's identical to it, and that shows us that there is an overfitting in our model. So we went in and we also looked at the weights of the columns and the effect of it on our prediction in RapidMiner. And we can see here that there's 2 columns that are almost 1, and that might be impacting our decision and our prediction. So what we thought is that we should go back to the data, and maybe we should change some of the fitting and maybe change some of the columns on it. So what we did is that we reduced our column numbers here to 98 columns, and we have did some cleaning on it and cleansing and normalization for the data. And then we took a look at which columns that have good data in it. So we can see here that this attribute or the fun is not a skewed data, and this shows that okay, these are good columns that have good data. It's not skewed, so it's not gonna cause any overfitting or false prediction on this. Now after that, before we make our models again, we change some of the features of our model. So our decision tree, for example, we minimize the maximal depth for it to 14. For random forest, we have increased the number of trees but reduced the number of the maximal depth. And for gradient boosted trees, we have reduced the number of trees on it to 14 and the number of depth. And that's based on our findings in the first time. Now, before we also run the model, we took away our DECO and DEC, and you can see that those are the highest correlation columns in here, and that's what we thought affecting our prediction. Now, when we ran the model the next time, we have noticed a great improvement in our ML model. So in here, you can see that our decision or precision of the model went up to almost 97% and 96% in random forest and decision tree, and the rest of the models around 94%, 93%, which is a great fitting, and it doesn't look like it's overfitting in this case. Now we wanted to check in depth more of how our squared error do. Now once we took a look at that, previously we had almost a 0 in all of our models. Compared to this time, they're all kind of in a similar range, with decision tree higher error and then random forest the second higher, but they're all around the same range. Now in the correlation, so usually we would think that decision tree looks like our best model, but once we took a look at the correlation, we've noticed that decision tree is giving us a 0 correlation, which doesn't make any sense in this case. It means that there is some overfitting and the model was over predicting in this case. But random forest is showing a great potential, and all of the other ones previously were almost at a 0.9 or a 1 correlation. Now they're all at 0.5 correlation, which is a very good range to be in. Now when we took a look at the ranges and the weights, they're almost all around the same weight, so we know that there is no specific columns that are messing up our prediction. So by looking at all of the previous details in our model comparison and kind of the journey that we've done, having to clean the data, having to rerun the models with different configuration, we got an outcome that using RapidMiner, we've noticed that random forest was the best ML model to use in this case to predict the gender selection. The reasons for that being that it's the second highest precision model, and then also the decision tree had a bad correlation coefficient, which was a 0 in this case, compared to the random forest, which was in a good range. The third part, the model had a good error square root, and also it was easy to understand the prediction chart when we looked at it, and the simulator was easy to play with. Now moving up to the next step is that we're going to take a look at the same data but in a different tool. We kind of wanted to look at the data from different aspects. Now using the Sas Viya, we did some data collection, and you can see here this is kind of our profiling for the data. Looking at all of the columns, you can see here each column and how is it, if it's unique, if it has any percentage of null values, what's the mean, what's the median, and what's the standard deviation, and all of this information. That way, if we notice any faulty data or too much null values, we can simply take that column out from our modeling. Now we did our data transformation and visualization. So the data transformation is to transform our null values to any to be an empty string in this case, or an empty number, and then we started partitioning for the model validation purposes. And you can see at the bottom here, this shows us our measurement details, the standard deviation, the standard error, and the distinct counts, and all of these details about the data. And this is the picture like in a more visualized way. You can see that we have the kurtosis, the skewness of the data, that the data is not skewed, only slightly up in the normal range. Now the second part is that we wanted to look at what are we going to predict that using this tool. So how are the men currently ranking the women. So you can see here that the men ranked the highest on intelligence, followed by sincerity and ambition, which means that women are mostly attracted to intelligent and sincere guys. And you can see here, using this box plot, we were able to figure out these details just from data without doing any extra prediction. So that's how we got that one. All right, now after that we started doing our automated analysis. So you can see here from the automated analysis, it gives us the whole details about which section tells us that 16% of speed dates ended in a match, and what are our top predictors to kind of that gives the decision for the opposite sex if there's a match or not. Also, we have what's called the predictive variable insight. When we run this, that tells us if there is a column that's not going to be needed for our prediction. So you can see here, for example, undergraduate school by male, this category was rejected because there was too many distinct levels in that column. So that means it's going to affect our prediction in a wrong way. So using this tool, we were able to kind of remove any redundant data or any not needed data or columns from our model. After that, we started building our model. So our first model here was a decision tree. And you can see here that the tool gives you a full visualization of what are the variable importance. So you can see here the fun score by female, attractiveness, and shared interest were the top ones. And then it gives you also the misclassification. So for the misclassification on the training and the validation, we're pretty close in here. And then it shows you how the tree is built, how all of our no decisions on the matches are going to the right leaf, and then all of the yes decisions are going to the left leaf. Our validation for the misclassification rate was about 0.16, which is a pretty good range in this case. And then we ran our gradient boosting. So for gradient boosting also, we had an iteration plot that gives us how many iterations went through our trees, and then the same thing as far as the misclassification rate and the misclassification frequency and the false positive and the true positive in this case, and what are the top variables that are affecting this. And you can see here that our validation misclassification rate went down in this case for that model to 0.14 compared to 0.16 on the decision tree. And then we lastly did our neural network, and in here this gives a really good precision. And you can see here it went down, and the validation misclassification rate to 0.12, and it also built a really good iteration plot. And our frequency for the misclassification for the true positive, true negative was really good as far as the training and the validation data sets. And now if we take a look at what's called a comparison in Sas Viya, it gives us the full fit statistics, the relative importance, and the lift fit. So you can see here in the top we have our model, which is the gradient boosting, and then after that comes the neural network, and then at the bottom here we have our decision tree. So you can see here our misclassification rate was the lowest on neural network. So the comparison basically made that model as the winner, and we can see that because it has the lowest misclassification rate, and it also had the realistic variable importance. And you can see that based on the true positive, true negative, and the confusion matrix, that gave us kind of the best model for that. So in here we used neural network compared to previously we used random forest and RapidMiner. So this kind of wraps up our view for today. And as you can see, we have explored the whole journey, and we've seen overfitting in some cases, how we can modify our data and how we can move forward with it, and we've done that using multiple tools. Thank you.